Hello everyone again. This is lecture 2 part 2 of current electricity. In the previous lecture we concluded the concept of Ohm's law, in which we understood two different things, that is resistivity and conductivity, and finally a relation between the capital E and J value was being defined. Today we will go on with the drift velocity concept and the origin of resistivity, and we will move on with our further discussions. So let us not waste any time. I am Sameer Lavankar. Let us begin our discussion. Okay. So, the course outline for you first of all. So, we started with the introduction concept, in which we understood that what is the difference between the movement of charges or the charges being at rest. So, being at rest was a previous concept, previous lecture, previous topic concept, in which you would have understood the value of charges, potential, etc. in the previous lecture of current electricity, before current electricity. In current electricity, what constitutes an electric current? Electric current is only due to the movement of charges from point A to point B. This complete concept was being understood in the introduction chapter. Then next was electric current. In electric current and electric current in conductors, we understood the concept of how can the current be defined, which is equal to small q by t. In infinitesimal method, we understood the concept of electric current as limit delta t tending to 0, del q by del t. In electric current in conductors, we understood the concept of how the amount of flow of charges from any point are being free or bounded can be defined in three main patterns. One was conductors, insulators and semiconductors. So, amount of charges which are free to move from point A to point B as long as the electric field is applied or not applied, the both cases were being heard in this concepts of 1, 2 and 3. Finally, in the Ohm's law concept, we understood the concept of what is the relation of V with respect to I, what is resistivity, what are the matters on which resistivity depends upon, what is the value of capital E, what is the relation of capital A with J, rho, etc., what is resistivity, what is conductivity, etc. That was the conclusion of the previous lecture. Today we will start with the fifth point, that is drift of electrons and the origin of resistivity. So, what is this drift of electrons? Let me explain to you beautifully. Okay, so drift of electrons and the origin of resistivity. So, please look over here very carefully. So, an electron will suffer collisions with the heavy fixed ions, but after collision it will emerge with the same speed but in random direction. So, first of all, for explaining the first point, I will have to look over the previous some of the cases. So, first of all, what was the assumption we assumed in this current electricity concept is that the electrons, first of all we should understand, let me write here 2-3 points. So, first of all, that movement of charges constitutes an electric current. Movement of charges constitutes an electric current. First of all, you should remember this thing. Second thing is that the value of okay. So, in current electricity, the assumption which we made is that this movement of charges or this movement will be only and due to negatively charged particles. Negatively charged particles, or we can designate them as electrons. Okay, so this thing is also being explained. Next thing is we understood that there may be negatively charged particles also and positively charged particles also. Next assumption which we put was that positively charged particles will be fixed. So, these two were the assumptions which we need to make for this current electricity concept. And now, after this reading this line, we also put on a different assumption that the amount of energy dissipated after collision is 0. That is, if the amount of electric energy which the electron had before collision is equal to the energy which it had after collision. Hence, the velocity is not changed, only the direction is being changed. This assumption was also being used in the previous subsequent slides also. So, I am just iterating it again only, that after collision the velocity will be same, but only the direction will differ. That is, the energy is conserved, there is no dissipation of energy. Okay. So this was the assumption. So just iterating everything again. So it was nothing but movement of charge constitute an electric current, and the assumption is that the movement of charges will be only and only due to the negative electrons, negatively charged particles, and the fixed ions will be positively charged particles. Hence, as an electron is a negatively charged particle, it will suffer collisions. Why it will suffer collision? Because these are only bound to be moved from point A to point B with the heavy fixed ions. Whom it will collide with? They will collide with the heavy fixed ions. But after collision, it will emerge with the same speed but in random directions. Quite evident. I explained you this also, that the velocity will differ, but only the direction may change. This is a typical example of that only, that after the collisions are being happening, there is a direction change in the movement direction of movement of electrons. Okay. So if we consider all the electrons, their average velocity will be 0. Quite evident. This was also proved in the previous subsequent slides only, that because the directions are being changed and these are vector form, only the summation of all the vectors is nothing but 0. So if we consider all the electrons, their average velocity will be 0, since the directions are random, quite evident. Thus, if there are capital N electrons and the velocity of the ith electron at a given time is Vi, then nothing but the average of all the electrons, it is nothing but addition of all the velocities. So because it is a vector quantity, if the velocity vector is in this direction of, let us say, one electron, and let us say another is in this direction, then the velocity gets cancelled up. Similarly, let us say this is the complete space in which there is a movement of electrons. So if something is like this, because you are taking the complete scenario into sequence, if some velocity of an electron is in this direction, you will find another electron which is moving in this direction. Similarly, if something in this direction, you will find an electron which is moving in this direction. Hence, when you try to add up everything gets cancelled out, and hence the complete average is equal to 0. Therefore, we can write that nothing but summation Vi by capital N is equal to 0. Okay. Now consider the situation when an electric field is present. Electrons will be accelerated to this field by capital A is equal to small e capital E by m. Please remember this formula. I think this was also being explained you in the previous topic of before current and electricity, that was charges. So please remember now, even if you do not remember from that portion, that capital A is nothing but small e capital E by small m, where minus E is the charge and small m is the mass of an electron. Consider again the ith electron at a given time t. This electron would have had its last collision some time before t. So we are assuming we are making a complete scenario to derive the concept of drift velocity here. So consider again, so we are considering that ith particle, and at a given time t, the electron would have had its last collision some time before t. So at some time before t, if I make a timeline here like this, and this is the point at which we are now trying to define something. So we are assuming that just before this time t, at some point before this time t, there would have had a collision of this electron already. Okay. And let ti be the time elapsed after its last collision. So let us say I am denoting that this was the point at which the last collision would have happened, and let us say this is the time ti. Okay. So if Vi was its velocity immediately after the last collision, then its velocity capital Vi at time t would be what? So let us suppose that they are assuming that if the velocity immediately after last collision, so let us suppose the velocity is Vi at this portion immediately after it. So this is the, let us say, if I try to, so after this, immediately after, so this is the point at which I am trying to find out the velocity just after collision, and now the next concept is we need to find out the velocity what is happening at time t is equal to small t. So this is the velocity we need to find out now. So what is this velocity? Let me try to explain again. So this thing is explained now. So that capital velocity nothing but capital small Vi minus, because there is an acceleration happening in opposite direction which will try to de-accelerate it. Hence the value will be nothing but small Vi into small e capital E by small m into Ti. I will try to explain it here also. So it is nothing but because there is a de-acceleration happening, therefore the value of velocity capital Vi will be nothing but small Vi. There will be a minus sign. Why there will be minus sign? Because de-acceleration is happened, therefore the velocity is reduced. Therefore capital Vi is equal to small Vi minus small e capital E by m into Ti. Why Ti? Because velocity the time from the small Vi to capital Vi was small ti. Hence this is the expression which we got. Next, since starting with its last collision it was acceleration of a time interval Ti, the average velocity of the electrons at time t is the average of all the Vi's. Again, if we need to find out the average velocity at the time small t, then it is nothing but the velocity concept of capital Vi in all the directions of all the electrons, and hence you can find out the value of small Vi also here. Till now what we understood is the value of addition of all the average at Vi was nothing but 0. Okay. Next line says that the average of Vi's is 0 since immediately after any collision the direction of the velocity of an electron is completely random. Again the simple explanation of second point is explained again here. The collisions of the electrons do not occur at regular intervals but at random times. Let us denote that by tau the average time between successive collisions. Now there may be a haphazard, so that I will try to explain everything here because there are many terms being explained. So first of all let me make a timeline. So this is the time t at which we are finding out the velocity which was coming out to be capital Vi. We are assuming before this was the point at which the last collision would have occurred, and the time difference between these 2 points was nothing but small ti. The next is the value of velocity at this point immediately after collision. Please remember it is immediately after collision, so it is after this portion here, which is equal to small Vi. Then next concept is we are finding out, we are denoting a new concept called as tau. What is this tau? This tau is nothing but the average time between successive collisions. So let me write it first here and then I will try to explain. So average time between successive collisions. Okay. So let us suppose this is a timeline of an electron which is denoted by capital 1, first number, and let me make another timeline for some another electron which is having, let us suppose this is the timeline I make, let us say this is a small time t, and let us suppose this is a small Vi, and let us suppose this is that capital Vi. Now here this time is again denoted by, let us say Ti dash. Please remember this Ti dash will be different from this Ti. Why it will be different? Because as the direction of movement of electrons are completely random, therefore we can directly denote that the amount of time required for every electron moving in random direction will have a collision at different times. Let us suppose that these are 3 electrons, this electron will reach it if the distance is less, but this may require more time because it has to reach at a larger distance, hence that amount of time will be different. Hence as the value of Ti dash is not equal to Ti, therefore we need to define something called as small tau. What is this small tau? Small tau is nothing but the addition of all these Ti's. So it is nothing but let us say I write it as small Ti addition divided by complete number of electrons. We are denoting the complete number of electrons as capital N here. So this is nothing but the value of tau. So this was, so I explained you everything here. So every point which was explained in the previous point is here. So this is small Vi here for you, this is capital Vi for you, and then this is small tau for you, and this is small ti for you. So everything has been explained now. So let us denote by tau the average time between successive collisions. Then at a given time some of the electrons would have spent time more than tau and some less than tau. Quite evident, that is the basic concept of average. What does average mean? That the 50% of particles are below them and 50% of particles are above them. We are just finding out the mean value here. So there would be some particles which will have a collision time which is greater than tau, and there will be some particles which will have a collision time which is less than tau. So this is the conclusion of the statement. Here only thing to be understood is nothing but that because of the deceleration happening, the velocity at some time after Ti is nothing but small vi minus small e by capital E multiplied by capital E upon m into Ti. Okay. Let us move on. So in other words, the time Ti in the above equation will be less than tau for some and more than tau for the others. Quite evident. So this was the value of tau, sorry, this was the value of Ti. So for some value it may be smaller than small tau, and for some value the value of Ti will be greater than tau. As we go to the values of I is equal to 1 to 2 n. So these are nothing but the electrons only. Okay. So, this thing is also been explained. Next is the average value of Ti is then known as tau, and this is known as relaxation time. So, a new concept has been explained here, that is what is relaxation time. Relaxation time, that is denoted by small tau, which is equal to summation of Ti upon capital N. Okay. Next concept, thus averaging the above equation over the n electrons at any given time t gives us the average velocity Vd. This is the average velocity Vd. So, till now if I make a table here, let us say what are the different denotations, we heard for velocities and what are different denotations we heard for time. So, first was small vi for you, that is the velocity of an electron at some time t before collision had occurred. We know that we do not know the time t, let me know the time as t dash. So, this was the time t dash, let us suppose. Then there is some velocity which is capital Vi, which was at some time t. Then there was a difference of time between Vi and small vi would have occurred, that time is denoted by Ti. Okay, so this thing is also been explained. Next concept is that we are assuming a time called as small tau. This is nothing but there is summation of Ti by n, Ti by capital N. Now there is a concept, there is a denotation which is known as small Vd. Now what is this Vd? Vd is nothing but the average of let me do it like this. So, this is nothing but the Vi, summation of all the Vi upon capital N. So, this is the crux of everything we have heard till this point. So, we understood first of all the small Vi concept at some time small t dash, then capital Vi concept at some time capital small t, then the difference of the velocities were happening at a time called as small ti, then there was something called as relaxation time which is equal to denoted by tau, which is equal to summation Ti by capital N, and there is now something called as Vd, which is called as summation capital Vi by capital N. This Vd is nothing but called as drift velocity. This is your drift velocity. Okay, so I have explained everything, let me just iterate everything statement from here. So, thus averaging the above equation over the n electrons at any given time small t gives us the velocity of average velocity. So, now what is average velocity? Average velocity is nothing but capital Vi average, which is equal to small Vi average minus E by m Ti average, as this value is constant. So, it will not be this can be put out of the average concept. Now, Vi average is nothing but 0. So, this is being already explained here. If where it is given, yeah, so average of velocity of small vi is again always anyways 0. So, if I use this as equation number 1, so I am just using that equation here in this concept. So, in this concept that equation is being used, and hence this is due to 1. Then small e by capital M is a small e capital E by small m into Ti average. So, in this explanation we I already explained that small Ti average is nothing but capital tau, a small tau. Therefore, finally what we got is Vd is nothing but minus small e capital E by m into tau, and this is nothing but the concept of drift velocity. Okay. So, next line is that this last result tells us that the electrons move with an average velocity which is independent of time, it does not depend on time. The value of small tau has been calculated for the average of everything. So, we know that value, it does not depend, it is not a function of the velocities of its collision with the previous head or after head, or let us say some time t plus delta t value, it is only dependent on some time called as relaxation time. That relaxation time is also a constant here which can be calculated directly. Therefore, this last result tells us that the electrons move with an average velocity which is independent of time, although electrons are accelerated. This is the phenomenon of drift, and the velocity Vd is called a drift velocity. So, hence there is concept called a drift. So, something is drifting apart, because something is drifting apart, and because it is a velocity concept here, hence it is called as drift velocity. Therefore, we understood a new concept here. So, let me conclude it here. Finally, Vd is nothing but minus small e capital E by m into tau. So, this is the concept of drift velocity. Small is nothing but the charge, capital is nothing but the electric field, small m is nothing but the mass, and tau is nothing but the relaxation time. So, let me conclude it here only. I will try to just revise the complete concept of velocity and time in the next class, and then we will move on with the further discussions. So, let me stop it here. Thank you.